Today we're going to be talking about arcs and how they correspond to different chords. So in the same circle or congruent circles, if there are congruent arcs, that gives you congruent chords. If you have congruent chords, then you have congruent arcs. So B is demonstrated with the first equation. If WZ, if that chord is equal to XY, then this arc WZ, and we denote that with a little arc over the top, is congruent to XY. A is demonstrated by our second equation. If you have congruent arcs, so now XY is going to be equal to WZ, then the chords that those arcs break off are going to be congruent. So our first example, we're solving for MN, the length of arc MN, not the length, the angle measure, I should say, or the arc measure. So I know that 85 plus 65 plus arc MN plus arc QP is going to equal 360 degrees. Well, we have 85 plus 65. That's 150. MN and QP are the same thing, so that's like saying twice arc MN is equal to 360. Subtract 150 from both sides. You get 210. Divide by 2. You get arc MN to be equal to 105 degrees. And remember, that's standing for how many degrees in this arc. It's not the arc length. We're going to talk about arc length later on in the year. Another theorem from this section. A diameter that is perpendicular to a chord bisects the chord at its arc and its arc. So what that means, I have a diameter. Goes through the center of the circle. It's perpendicular to our chord. So therefore, DE is going to be congruent to EF. But also arc DG with a little arc over it is congruent to GF. An example involving that. Solve for MN. So what do I have here? I have a diameter. Well, the diameter is perpendicular to NM, and I have it even marked off the congruent pieces for us. Well, QP is a diameter. So therefore, arc QMP is going to be 180 degrees. Thus, that makes PM equal to 50. Now, if a diameter is perpendicular to a chord, it bisects the chord, but it also cuts into two congruent arcs. So arc PM is equal to arc NP. So that's also 50 degrees. So arc MN, and that's the minor arc because we have two. We're just listing it by two letters, is going to be equal to 100 degrees. So in the same circle or in congruent circles, if two chords are congruent, if and only if they are equidistant from the center. So what that means in terms of some equations, AB, that chord is congruent to CD. If and only if it is equidistant. Remember, distance from a point to a line is a perpendicular. So if and only if EF, segment EF, is congruent to segment EG. Remember, equidistant, distance means a perpendicular from a point to a line or a line segment. So the next one, we're looking for FC here. Well, I know that distance there, which is perpendicular, is equal to that distance there. So chord AG is equal to EF. But this is also a diameter. So the diameter bisects chord AG, making, I'm going to call that X, XG equal to 4. But also, EC is equal to AG, so each one of those segments is 4, making FC equal to 4 units long. In circle O, the measure of arc RS is equal to 70, and I should have a little degree symbol in there. But now chord RS is equal to 20. We need to find the center of radius O. So in our circle, we have circle O. We have RS. That arc length is equal to 70. Our chord is equal to 20 units long. We're looking for OS or OR. Angle ROS is a central angle. Therefore, angle ROS is equal to the arc that it lays off, so that's equal to 70. So let me draw a different picture of that over here. We have ORS. Angle ROS is equal to 70. RS is equal to 20. We need to find either radius, which is OS or RO. Well, we know those are equal because all radii of a circle are equal. So it's an isosceles triangle. If I drop down a perpendicular, Rx is going to be equal to 10 because the perpendicular, the altitude in an isosceles triangle to the base bisects the side and also bisects the angle. So 35. Now I have a right triangle. I need to find the hypotenuse. I'm given the opposite, so that's sine. Sine of 35 is equal to the opposite over the hypotenuse, what I'm looking for. Multiply both sides by x. Then divide by sine of 35. So then 10 divided by the sine of 35, that's going to be 17.43. And that's the radius of our circle. Next example. Sketch circle Q with chord RS that is 16 centimeters long and 2 centimeters from Q. What is the radius of Q? So circle Q, chord RS, that is 16 centimeters long, so that's 16, and 2 centimeters from Q. So the perpendicular, the distance is 2. What is the radius? X. Well, the radius, or even a diameter, perpendicular bisects this chord, so therefore that is 8. So what do we have there? We have a right triangle. where we're looking for the hypotenuse. One leg is 8, one leg is 2, so x squared is going to equal 8 squared plus 2 squared, 64 plus 4, x squared is going to equal 68, so x is going to equal the square root of 68. There's a perfect square that I can pull out of there, because 4 times 17 is 68, so that's 2 root 17, because I'm pulling out the perfect square of 4, so it's 2 root 17, and let's make sure we have units in there, centimeters. Our last example. Plane P cuts sphere O in a circle that has a diameter of 20. The diameter of the sphere is 30. How far is the plane from O? So I have a sphere. We usually draw a sphere like a circle, but then we draw a little oval in the middle. So it tells me that it's three-dimensional. Sphere O. Now I have a plane that chops off a piece. Think of cutting an orange. When you cut an orange with your plane of your knife, that cuts off a small circle. Well, the diameter of that circle is 20, therefore the radius is 10. The diameter of the sphere is 30, so the radius of the sphere is 15. I am looking for x. We have, again, another right triangle where I have 10, 15, x. X squared plus 10 squared is going to equal 15 squared. X squared is going to equal 15 squared is 225 minus 10 squared, which is 100. X squared is going to equal 125. Square root both sides. 125 is 25 times 5, or 5 root 5. Do I have units? Does it give me units? So our answer is just 5 root 5. There are your 2 lesson questions for the day.